Now in this case, we're doing something similar, except we're doing it for ethanol. When you burn ethanol, alcohol, and it combusts into carbon dioxide and water, we're looking for the standard enthalpy change, in this case, right here. So we know that the standard enthalpy change is equal to the sum of N times the standard enthalpy of formation of the products minus the sum of the standard enthalpy change of formation for the reactants. So in this case, our balanced chemical equation is going to be C2H5OH plus O2 goes to CO2 plus H2O. So balancing this reaction, I know that I have 2 carbons on the left side. I'm going to need 2 on the right side no matter what. That gives me 2 carbons, 6 hydrogens, 3 oxygens versus 2 carbons, 3 oxygens, and 2 hydrogens. So I'm going to put a 3 in front of this guy right here, which will change this to 6 hydrogens. And now I have a total of 7 oxygens. So I'm going to need a 3 right here, and that's going to balance my equation. It's going to give me a total of 7. So now that I have my balanced chemical equation, the rest of this isn't too hard. I follow the exact format given here and look first for the sum of the enthalpy change of formation for the products, which happen to be CO2, 2 times the standard enthalpy of formation of CO2 plus 3 times the standard enthalpy of formation of H2O. And then that's going to subtract from the standard enthalpy change of formation of the reactants. This case, this is going to be the same thing as 2 times negative 393.5 kilojoules per mole plus 3 times negative 285.8 kilojoules per mole minus this guy right here, sum of formation of C2H5OH, which is going to be negative 277.7 kilojoules per mole. Right there. So, just to clarify this a little bit, I'm going to get rid of that really quickly to show how I got that value. This is the standard enthalpy formation of the reactants, which in this case I only have to deal with one, which is C2H5OH enthalpy of ethanol, but I have no coefficient, so it's going to be 1, which if you look up here, the value is negative 277.7 kilojoules per mole. 277.7 kilojoules per mole of reaction. So when I do the math on these guys, I'm going to get 2 times negative 393.5, which is going to equal negative 787 kilojoules per mole of reaction, plus 3 times negative 285.8, which is going to give me a negative 857.4 kilojoules per mole of reaction, subtracted by a negative 277.7 kilojoules per mole of reaction. And I'm going to get a total value of, hold on while I do this calculation really quickly, a total of negative 4.4 kilojoules per mole of reaction plus 277.7 kilojoules per mole of reaction, which is going to give me a total of negative 1,366.7 kilojoules per mole of reaction. And that will be your final answer. Thank you.